Hello, science fans. Today we're diving into something truly amazing. The Celonis ML Workbench. Think of it as a super-powered laboratory for your business. Businesses have all these invisible paths they follow every day, like how they buy supplies or help customers. These paths are called processes. Sometimes these paths get tangled up, causing delays and problems. The ML Workbench is a special tool inside Celonis that uses artificial intelligence, or AI, to look at these paths, understand them, and even predict what will happen next. It's all about making businesses smarter, faster, and more efficient. Consider this. It's science in action, but for business. So why would a business want to use this digital lab? It's all about seeing the future. Imagine you could know ahead of time which customer orders might be late. Or what if you could spot a problem in your supply chain before it even happens? That's the power of predictive analytics. That's the power of prescriptive analytics. Predictive means guessing what will happen, and prescriptive means suggesting what to do about it. The ML Workbench gives data scientists, the brilliant people who work with data, the power to build custom AI models. These models are like crystal balls, but instead of magic, they use math and data to find hidden patterns and make incredibly useful predictions. Now let's compare this to other machine learning tools. Many platforms out there can build AI models, and they are fantastic. But the Celonis ML Workbench has a secret ingredient. It's directly connected to something called process mining. Process mining is like creating a perfect X-ray of a business's operations, showing every single step, twist, and turn. While other tools might just look at numbers in a spreadsheet, the ML Workbench understands the story behind the numbers. It knows the sequence of events, how long each step takes, and how different activities are connected. This deep process understanding makes its predictions incredibly accurate and relevant to improving the business. This special connection to process data is what makes it a game changer. It's not just about building a cool AI model in isolation. It's about creating a model that speaks the language of the business. When your AI understands the flow of work, it can give you insights that are immediately useful. For example, it won't just say, sales might go down. It can say, sales might go down because this specific step in your order process is taking 3 days longer than usual. This context is everything. It turns a general prediction into a specific, actionable piece of intelligence. It's the difference between knowing it might rain and knowing you need to fix the leak in your roof right now. All right, let's open up this amazing toolkit. The heart of the Celonis ML Workbench is its notebook interface, like a scientist's lab notebook, but digital. It uses Jupyter notebooks, a favorite tool of data scientists. Inside these notebooks, you can write code, see results immediately, and add notes and pictures. The main programming language is Python, like the Swiss Army knife of data science. The workbench comes preloaded with important Python libraries and is ready for experimentation. But what do we feed our AI models? Data, of course. The ML Workbench connects easily to the event log. Think of an event log as a detailed diary of a business process. It records the activity. It records the case ID. It records the timestamp. This case activity timestamp structure lets us reconstruct an order's entire journey. Loading this data is the first step. Pre-processing is preparing the data, like washing vegetables before cooking. Real-world data can be messy. Sometimes values are missing, nulls, and we must decide how to fill them. We do feature engineering, creating new useful information from existing data. For example, from 2 timestamps, we calculate a duration feature to show how long a step took. Now choosing our model. For clear yes-no predictions, we use supervised learning. Example, will this delivery be late? A great algorithm is random forest, like asking a forest of decision trees. For finding groups or outliers without a specific question, we use unsupervised learning. Clustering finds groups of similar orders we didn't know existed. The right model depends on your question. So we've built a fantastic model. That's great science. But how do we make sure it's a good model? We have to test it, or in data science terms, evaluate it. We do this by showing it data it has never seen before and checking how many of its predictions were correct. A common trap here is something called overfitting. This happens when a model learns the training data too well, like memorizing the answers to a test instead of learning the subject. When it sees new, slightly different questions, it gets confused. To avoid this, we use techniques like cross-validation, where we train on different slices of the data and test on different slices of the data to ensure it's learning general patterns, not just memorizing. Another important challenge is dealing with imbalanced data. Imagine we want to predict which invoices will have a rare payment error. Maybe only 1% of all invoices have this error. If our model just learns to predict no error every single time, it will be 99% accurate, but it will be completely useless because it never finds the problem we're looking for. To fix this, we can use techniques like oversampling,